Hello everybody and welcome to our interactive maths lesson. We are looking at fractions today, continuing our work on fractions. So hello, I saw you saying hello while you were waiting in the lobby and waiting for the lessons to start. So thank you for that. Can you, as somebody's already said, I'm new to this and looking forward to today's session. So we're looking forward to working with you as well. Welcome. Tell me where you're from, London, Manchester, Cardiff, Edinburgh. Just give me the region where you're from. It's quite nice to see where everybody is and say second time, first time, fifth time, 13th time if you've been with us from the beginning. This is the 13th lesson that we've done. Let me see who you are and where you're from. I hope while you've been waiting, you've been looking at our brain teaser, but it's on the board. And we are all very, very busy at Bright Idea Education trying to finish our app submission. So we've got a new app coming out. And that app, our first subject we are working with is maths. We'll be doing lots of other subjects as well. And our aim is so that you, as the users, do not know the difference between fun and learning. That the graphics, the gamification is all so much fun that you just think, wow, I love normally, I love gaming, and now both of these things are together. So we're really, really looking forward to you. Now, we've had a few laggy issues with internet connections. If your internet gets a little bit laggy, then please do hit your refresh button. So I'm new. We've got some new people. Sorry, 13th time. Wow, being with us from the start. Excellent. Well done. So maybe we get you to take the lesson next week because you're with us from the start, so you really know what's going on. So lovely, lovely, lovely. Fantastic. So have a look at the brain teaser. Now that first question says, Mo is comparing the fractions 3/7 and 6/11. 3/7 and 6/11. Now what is going to go in there? Greater, equals than, less than. Now Mo says he's going to find a common denominator, which of course he can, and he can multiply the denominators. They're both prime numbers. So they're not going to be in the same multiple family, not going to be multiples of the same number. So it says it's going to find a common denominator. Do you think this is the most effective strategy, or can you think that there might be another way of doing it? There might be another way of doing it. What do you think? Shall we find a common denominator, or is there an easier way? Is there an easier way of solving this problem? Is there an easier way? Let me have a hear of your ideas. Let me hear your ideas. Tell me. Is finding a common denominator the most effective way? Anybody got any other ideas? Okay, 11th time, same here. Brilliant. Got some old timers here, and we got some new people as well. Brilliant. And we'll have some people in the middle as well who've been here for 5 or 6 times. There isn't. You have to find the denominator. Interesting. Interesting. There is another way, but I'm wondering whether you know it. Yep, you can cross multiply the denominators, and you could put them. You could say, okay, they're both prime numbers, so I'm just going to have to multiply them and find the common denominator, which was 77. And then you've got to do, well, what did I do to 7 to 77? Well, I multiplied by 11. 3 11s are 33. You're not seeing that when I put the O, so let me just bring it a bit nearer. So let me just see if I can just give you a little bit more. Just caught on my chair. A little bit more screen. A little bit more screen. There we are. That's better. So we could say, okay, then let's put them both over 77. That's a common denominator. We could put them both over 77. And then we could say, okay, what did I have to do to 7 to make it 77? I had to multiply by 11. 11 threes are 33. Okay. What do I have to do to 11? To get 7, I had to multiply by 7. 6 7s are 42. 6 6s are 36. 7 6s are 42. So then I could say, okay, that's 33 77s, and that's 42 77s. So this one is bigger. Okay, I could say that one is bigger because it's got more 77s. I can do that. I can do that. That's quite complicated though. I could look at the numerators. Anybody got an idea what you could do with the numerators? Everybody else in here? So common denominator is what you're thinking about. Has anybody ever done any work with numerators? Has anybody ever done any work around using the numerators? Because you could look at this and say, well, if I make them have the same numerators, then I can just compare the size of the fractions. I can say, oh, well, if I make this 6, if I double this and double the bottom, because I've got whatever I do to the top, I've got to the bottom, so I could make the numerators the same. Let's see how that looks if I make the numerators the same. So if I make that 6, I've doubled it, I have the bottom. Okay, so the equivalent fraction, 6/14 is the same as 3/7. And with the numerators the same, 6/14 and 6/11, we know the bigger the denominator, the smaller the pieces are. A cake shared by 14, a cake shared by 11. So we can see that 6/11 is going to be bigger than 6/14 because the 14s are smaller. So sometimes you can make the numerators the same and then look at the bottom. So that was an easier way of doing that. Oh, well, 6/14 is smaller than 6/11 because 14s are smaller than 11s. If you had 6/14 of the cake, you would have less than if you had 6/11 because 14s are smaller than 11s. So anybody ever done that before using the numerators? Well, the smaller the numerator, the bigger the fraction. The smaller the denominator, the bigger the fraction, not the numerator. The denominator tells you how many groups a fraction has been split into. The numerator tells you how many of those groups you've got. So if we have a look, I put my fraction chart away. Get it back. Okay, just see if I've got my fraction chart here. I could put one on the screen. But if we have a look at our, let's just go big screen for a moment, because nobody gave the answer to that. So if we have a look at our fraction, okay, and we look at 1, 1/2, 1/4, 1/8, 1/5, okay, 1/12. And the bigger the denominator, the smaller the fraction, because it's been split into more pieces. Yeah, whatever you do to the numerator, you have to do to the denominator. So we double the numerator and we double the denominator. Okay. So the bigger the number at the bottom, the bigger the numerator, the denominator, the more it's been split into, the more it has been split into. We'll just drop this down to see if it's a bit easier for you to see down here. Okay, let's see if it's easier for you to see. There's a lot of buffering going on today, folks. I'm really, really sorry. A lot of buffering going on today. The internet is obviously really struggling. So if we drop this down, so we have a look. This cake has been split into quarters. This cake has been split into thirds. 4 is bigger than 3. These are 1/3. 4 has been split into 3. This is 4s, this is 3s. A quarter is bigger, a quarter is smaller than a third. That's just got to be shared by 3 people. This has got to be shared by 4 people. So the bigger the number at the bottom, the more equal groups a whole one has been split into. So the smaller the pieces are going to be. The smaller the pieces are going to be. 1/2 split between 2. 1/4 split between 4. We are very blurry. Now this is a internet issue. This is an internet issue. The signal's really, really poor. Just refresh your pages for me. Just refresh your pages for me. Let's try and refresh. The little arrow that goes around in a circle. So just remember, the bigger the denominator is 6, 10, 12, 5 is a bit smaller, So 6 are smaller than fifths because it's been split into more pieces. Okay, so it sounds a bit confusing because we think about bigger numbers getting bigger, but not when they're fractions of a whole one. Not when they are fractions of a whole one. So we're going to stay down here and we're going to do some more work. But there's a connection problem. Who's still with me? I'm going to bring you up so I can see this screen. And sometimes the screen freezes. Have you all refreshed your screens? Have you all refreshed? Have you all refreshed? There's a lot of lag. I'm just going to wait until I give you a chance to all refresh your screens and get your connection back. Because I want to do some work. I'm going to keep it up here so I can see if my second screen is blurry. So let's have a look at simplifying some fractions. I've got some fractions here. So we're going to do a little bit of work just to refresh your memory, and then we're going to do some adding. Okay, you back? So can you simplify for me, please? 2 4/10. What's the simplest fraction that can be shown as? 2 4/10. We're going to do some simplifying, some comparing, some equivalence, some ordering, some addition, some subtraction. What's the simplest fraction that could be? What's the simplest fraction that could be? If I do the numbers bigger, even though it's blurry, you've got a better chance of seeing them. So you're looking at the highest common factor. The highest common factor, well, 4 factors are 2 and 4. 10 factors are 2, 5, and 10. So the highest common one is 2. So you're going to divide by 2 each one. Divide by 2. So 4 divided by 2 is 2. 10 divided by 2 is 5. Okay. What happens with this whole number? The whole number just stays unchanged, because 2 whole ones is quite simply 2 whole ones. Yeah. So 2 4/10 goes to 2 2/5. People have written 2/5. Don't forget the whole one. Okay. And it was 2, not 1. Don't forget the whole one. That does not get left out. Okay. Let's try another one. 3 4/8. What's the simplest fraction at 3 4/8? I'll do work up here because at least when it's blurry you can still see. 3 4/8. Exactly, nothing happens with the big one. When you're simplifying, nothing happens with the big one. It just stays there. 3 4/8. Okay. Looking at the relationship, we can see that's half of the bottom. So we can take that to 3 1/2. 3 1/2. We can take that straight away. Okay. Simplify this one for me. Oh, there's an awkward fraction. There's an improper fraction, an awkward one. Oh, excuse me, could I have 32/10, please, of cake for my party? Very silly to leave a fraction like that. How are we going to simplify that one? How are we going to simplify that one? 32/10. Ah. How many wholes can we make out of that? How many whole ones can we make? If we've got 32/10, every 10/10 we've got, we can make a whole one. So how many whole ones can we make out of that? How many 10s can you make out of 30? How many 10s can you make out of 30? You've got 32/10. For every 10/10, we can make a whole one, can't we? There are 30 10s, so 30 of those, 30 of the 10s will go. That's 10 plus 10 plus 10. So that's 3 whole ones. And then we've got 2/10 left. So it's 3 and 2/10. Is that the simplest way? No. You can simplify that again. What can that be simplified to? Common factor, 2 and 10. It can go to 3 and 1/5. Oh, we didn't see that. 3 and 1/5 is the simplest answer. So 32/10 go to 3 whole ones and 1/5 left over. 32/10 is top heavy. We can make 3 whole ones out of that. 10, 20, 30. Oh, that's 3 whole ones. And I've got 2/10 left over. Yeah, let's try another one of those. Because again, for some people, that seemed to be a bit new. The idea of having more than a whole one. So we've got more than a whole one here. We've got 32/6. That's a ridiculous fraction. We can't leave it like that. That's improper. It cannot be left like that. So first of all, let me see, you show me how many whole ones you can make. How many whole ones? For every sixth, it's a whole one. So how many 6s can you make out of 32? How many 6s can you make out of 32? How many 6s can you make out of 32? Well, 5 6s are 30, aren't they? 5 6s are 30. So we can have 5 whole ones and 2 6. Is that the simplest way that can be left? That's right, 5 6s. So you make 5 whole ones, but that would just be use up 30 of them, wouldn't it? Because 5 whole ones is 30 6s, isn't it? That's the same as that, because 5 6s are 30. But you've still got 2 6s left. So what can you simplify 2 6s to? You can simplify 2 6 to 1/3. So you're going to get 5 and 1/3 is going to be the answer. Okay, 5 and 1/3. That's right, 5 and 2 6. And then you can simplify that 2 6 to 1/3. You can simplify that 2 6 to 1/3. Okay, remember what I said, any point, if you're thinking this is a bit tricky, make sure you come in and join next week's lesson. Okay, let's get our brains working. We're going to do some comparing fractions. Make sure you've got a drink. Miss Nikki's going to have a little drink. I'm going to work up on the board because it's quite laggy, so I'm going to work on the board and write big. So even if you have got lag and blur, you can still see. Okay, we've got 4/10 and 3/5. I'm looking for greater than, equal than, or less than. 4/10 and 3/5. Okay, now if I didn't have a fraction chart with me, I'm not putting a fraction chart up. This is lesson 3, so this is assuming a good knowledge of fractions. And it's not a problem if you haven't, because you can join lesson 2 next week and build your confidence. I'm looking at that and I'm going to say, well, if I think about a half, I know that 10 is less than a half, but 3/3 is more than a half. That's what I would do there. I would think half or more than. Or I would think, do you know what? I'm going to make that into tenths. Wherever I do to the bottom, I've got to do the top. We can see there are multiples there. So 3/5 is the same as 6/10, isn't it? So I'd either convert that to tenths as well, so I could easily see, or I could think that's less than a half, that's more than a half. So quite clearly, that is more. Okay. Now somebody says 4/10 is less than 3/10, and I don't quite know where 3/10 is coming in. If you've made that tenths, you double the denominator, so you also have to double the numerator. You have to do the same to the whole thing. If you're doubling up, everything gets doubled. Everything gets doubled. Okay, everything gets doubled. So 3/5 is the same as 6/10, not 3/10. You double the bottom, you have to double the top. Otherwise, you have changed the fraction completely. It's no longer equivalent. Okay. So 3/5 is bigger than 4/10. So let's have a little think about what you can do to make life easier for yourself. Okay. Let's have a think about this. 3/8 and 3/6. 3/8 and 3/6. Now think about the numerator conversation we had. Oh, well done for noticing it's 6/10. Well done. Excellent. Think about the numerator conversation we had. Now I'm looking at this and I'm thinking those numerators are the same. So I can look at the denominators and say which fraction is bigger. Remember, the less sharing, the bigger the pie. The less sharing, the bigger the pie. If I have a cake and I put it into 6, I get bigger pieces than if I put it into 8s. I get bigger pieces than if I share it into 8s. So if I have 3/6, that's half the pie. If I have 3/8, it's not half the pie. 3/6, half the pie. 3/8, not half the pie. 4/8, half the pie, but not 3/8. So I can look at the numerators here. I can look at the numerators here, and I can see, oh, same amount of groups. What are in the groups? Oh, that's 6 groups. That's 8 groups. More pie if it's shared by 6. More pie. So 3/6 is bigger than 3/8. 3/6 is bigger than 3/8. Let's have a look at another one. 4/10 and 3/5. 4/10 and 3/5. 4/10, just keep refreshing. After a while, it asks you to refresh. The actual program asks you to refresh. So 4/10 and 3/5. Now, let's make them the same. I could think about halves. Oh, I think we did this when we started off with this one, didn't we? Put my things going the other way. So we know that 3/5 is bigger. We did that one. So let's have a look at the next one. Oh, an old favorite. We should be really easily answering this one. Would you rather have a third of a favorite pie or a quarter? This has been shared by 3. This has been shared into 4 equal groups. So which pieces are bigger? A pie shared into 3 or a pie shared into 4? The less sharing, the bigger the pie. The less sharing, the bigger the pie. We know 1/3 is bigger than 1/4. That's it. 1/3 is bigger than 1/4. Okay, let's have a look at another one. 5/12 and 1/4. 5/12 and 1/4. Now we can convert this to 12s, or exactly, I wouldn't say I'd have a third of the pie rather than a quarter as well. How many 12ths is a quarter? How many 12ths is a quarter? What's a quarter of 12? We could say, well, I know 3/12 equals a quarter. That equals a quarter. And I've got 5/12, so it must be bigger. Or I could say, let's make this 12s. Right, to make 4/12, I have to multiply by 3. So I have to do the same to the top. 1/4 is 3/12. 5/12 is bigger. Okay, 5/12 is bigger. So let's have a look at another one. Think about the easiest way, using the maths you know already. Last one of comparing. Which is bigger, 5/6 or 3/4? 5/6 or 3/4? Which is bigger, 5/6 or 3/4? Now I can't make the 4 into 6. So here I have to find that common denominator. So I'm looking for the highest common, the lowest common multiple I'm looking for. So if I go to the highest, that's for prime numbers. So I'm looking for the lowest common multiple. So let's have a look at their multiples. 4, 8, 12, 16, 20, 24, 28. Let's do 6. 6, 12. Oh, got it already. 12. So let's put them over 12. To put 6 over 12, I had to multiply it by 2. So I've got to do the same above. To put 4 over 12, I have to multiply by 3. So I have to do the same above. So that is 9/12. So that's the same as 9/12. And, oh, sorry, that comes first. That's the same as 10/12. And that's the same as 9/12. So we can see that this is just a little bit bigger. We had to go to the common multiple. We had to put them over a common denominator. Okay, let's have a look where we are and what's going to come next. So let's have a little practice at equivalence. Let's have a little practice. You seem to have come back now. So I'm going to try and drop you down and see if that works. If it doesn't, then I'm going to put it back up on the screen. And a few little examples that, oh, that looks good. We look okay. Okay. So let's have a look. Let's do the top one first. Let's take the bottom one out. Come on, chop, chop. These are quick. 5/6 is the same as how many 12s? So we're doubling the denominator. We have to do the same to the numerator. So 5/6 is the same as how many 12s? 5/6 is the same as 10/12. We double the bottom, we have to double the top. We double the bottom, we have to double the top. So look at the one underneath. 3/4 is the same as how many 12s? 3/4 is the same as how many 12s? What have we done to the denominator to make it 12? What do you have to do to 4 to make it 12? What did we times it for? Is it double 4? Is it triple 4? Is it quadruple 4? How many 4s are 12? 3 4s are 12, so we have to multiply by 3. We have to do the same to the top. We have multiplied the bottom by 3. To make that, we had to go times 3. So we have to do exactly the same to the top. 3 3s are 9. 3 3s are 9. We have to do exactly the same to the bottom as we have to do to the top. Okay, we seem to be back in focus. Happy days. 2/3 is 8 what? 2/3 is 8 what? Let's do that one first. 2/3 is 8 what? What has happened to the numerator? What did we have to do to 2 to make it 8? What did we have to do to 2 to make it 8? We have to multiply by 4 to make it 8. So we have to do exactly the same to the bottom. 3 multiplied by 4 is 12. So 2/3 is the same as 8/12, which is the same as how many 6ths? How many 6ths? Now you can either say what do you have to do to 12 to make it 6, and then do the same, or you can say what you have to do to 3 to make it 6 and then do the same. You can decide. So you can either say, oh, to get that I have to divide by 2. So I will do the same up here. I will divide by 2. You could go back to the beginning and say, what do I have to do to 3 to make it 6? I have to times by 2. So I'll do the same above. It all works out the same because it's equivalent fractions. Okay? Have a look at this one for me. Oh, it's so nice to have the connection back. Brilliant. Have a look at this one for me. 1/3 equals 1/3 equals. Okay, think to yourself. 1/3 equals. What are you doing to the bottom? You have to do it to the top. To get 3 to 9, I have to multiply by 3. So I have to do exactly the same to the top. And that gives me 3/9. That gives me 3/9. Whatever I do to the bottom, I have to do to the top. Otherwise, I am changing the ratio. They will no longer be the same ratio. So they will no longer be equivalent fractions. Okay, give me some possibilities. 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 3/4 equals 9/12. Yes, that's one possibility. Yep, I agree with that one. So we could have 3/4 equals 9/12. Are there any others or not? Because we can't change the ratio, can we? So 2 empty boxes, the ratio has got to be the same. If you've got those denominators, you cannot change the ratio. So if we're going to think about quarters and 12ths, the only answer we can have is that 3/4 equals 9/12. That 3/4 equals 9/12. Okay, hello latecomer, you have to join in from where we are now, okay? So we are looking at fractions and we are now going to think about ordering. Now we are thinking about ordering. Can you put those fractions in ascending order? Remember, ascending means getting bigger. Getting bigger. Now, again, let's look for things that make it easy. We can launch into finding a common denominator. Okay, we could launch into finding a common denominator. But I look at those 3 fractions and I say, oh, are they all as simple as they could be? And when I simplify them all, then it's much easier for me to order. It's much easier for me to order. Okay, they're going from smallest to biggest. Think about sharing. Think about sharing. Think about sharing. Okay, think about sharing. Smallest fraction to biggest fraction. Yeah, exactly. I thought that too. Let's get that simplified to a half straight away. That's what I would do. I'd say, well, I'm going to think about that as a half straight away. And then that makes life so much easier. And then I'm going to think about my pie. Okay, favorite pie. 1/3, 1/4, or a half of it. 1/3, 1/4, or a half of it. So you could think Let's put them in ascending order, or let's put them in best piece of pie order. Or let's put them in best piece of pie order. Well, a quarter is the pie shared by 4. A third is the pie shared by 3. Half is a pie shared by 2. You get much more. You get much more. Yeah? So in ascending order, there they are. Ascending order, a quarter, a third, and then 4/8. So look for the easy bits, making life easy for yourself. Okay, I want these in descending order. So the worst bit of pie, from the best to the worst bit of pie, from the best to the worst bit of pie. And look for making life easy for yourself. Okay? Look for making life easy for yourself. You could make them all a common denominator, or you could just look at 2 and know which side of a half they sit at. You already know which side 7/10 is going to sit at with a half, because you know that 5/10 is a half. 4/10 is over a half. So you just need to work out which is bigger, 7/10 or 4/5. Okay, so descend in order. You're going from best bit of pie to worst bit of pie. Starting off with the best, the biggest first. The one before, ascending, like ascending to the top of a mountain. You are climbing up to the top. This time you're at the top and it gets worse. First of all, you get the best bit of pie, and at the end you get the worst bit of pie. So, in descending order, because I made 4/5, I changed it into the equivalent fraction of tenths. So double the bottom, double the top. So straight away I could see that was 8/10, which is more than 7/10, which is more than a half, because 5/10 are a half. So make sure you know your fractions. You don't want to get cheated out of pi. You don't want to get cheated out of pi. Let's have a look at one more. We're going to go ascending this time. So we're saving the best till last. Ascending this time. We're saving the best until last. Ascending this time. We're saving the best until last. So the worst bit of pie first, then the next bit of pie, and the best bit is at the end. And the best bit is at the end. Now look for things you know. Look for things you know. You know what 3/4 is equivalent to in terms of twelfths. Okay, you know it's 9/12. Because 3/12 is 1/4, 6/12 is a half, 9/12 is 3/4. So you know that's at the end, and 3/6 you know is a half. So looking at those fractions, a half is the worst piece of pie. Okay, if you don't know how to do it, that's fine, but I would like you to join the 11 o'clock lesson, please, next week, to really lock this down. So we're thinking about equivalence. So we're looking at, okay, 3/6, we know that's a half. 3/4 is bigger. And we know 9/12 is 3/4. So that 10/12 is going to be the biggest one. Now, this is lesson 3, and lesson 3 is a bit tricky. We're going for it, okay? So if there's any part of this lesson you feel a little bit unsure of, then I would really like you to hop on the lesson 2 of next week, okay? So let's have a look at a little quiz. Let's have a look at a little quiz. Oops, it's jumped back. I said quiz and it ignored me. So here we go. Let's have a look at a little quiz, okay? So quiz 1 is going over what we have done so far. Quiz 1 is going over what we have done so far. So anybody that gets less than 80%, 60% or below, then it's really important that next week you join me on lesson 2, please. Because when you're at school, you don't always have a chance to go back over things that you're not sure of. And this is a brilliant opportunity to jump on even lesson 1 and feel really confident and think, that's what it is. Yeah, I do know it. So come in on those earlier lessons. Yeah, come in on those earlier lessons. Yeah, brilliant. Don't want you losing confidence. I want you building confidence, okay? Don't want you losing confidence. I want you building confidence. So the first question, we are looking at simplifying 10/18. Remember the box with me in the top gets in the way of the thin vertical line that you need to use to scroll down. Okay, simplify 10/18. Looking for the highest common factor. The highest common factor. Okay. So remember, if you're taking 18ths down to 9ths, you have divided 18 by 2, so you have to divide 10 by 2 as well. Whatever you do to the bottom, the numerator, you have to do the same thing to the top. Otherwise, you change the relationship between top and bottom, and it is no longer an equivalent fraction. So if you are simplifying 18ths to 9ths, that means you are halving 18. So you have to also halve the numerator. Okay, so what is half of 10? Now question 2, you have to choose the sign. 3/8 is greater, equal, or less than 3/6. So think about the work we did where the numerators are the same, then you're thinking about what's the best piece of pie to have. 8ths or 6ths? 3/4 equals what? 3/4 equals what? How many 12ths? Okay, so you're making 12 into 4 equal groups. 12 divided by 4, and if you had 3 of those groups, how many would you have? Which is the largest fraction? Okay, largest fraction, best bit of pie. Largest fraction, best bit of pie. Largest fraction, best bit of pie. I think about that 4/8 as a half. Okay, what's the best bit of pie? Largest fraction is not the biggest number, because the biggest number in the denominator means it's been split into more groups, so the pieces will be smaller. Biggest fraction is best pie. That's the way to think about it. Best piece of cake, best piece of chocolate, best piece of pie. Most biggest share of the money. The bigger the fraction, the more you get. And 4/5 plus 1/5, what does that come to? 4/5 plus 1/5. So remember, fractions are parts of the whole. So if you had 5/5, what have you got? If you've got 5/5, what have you got? You've got all of them, haven't you? You've got the whole thing. You've got 5/5, you've got the whole thing. Okay, let's end the voting. Okay, yeah, I hope everybody gets a good score, but this is about, these lessons are a chance for you to pop out of school, pop out of the lessons at school and just practice anything that you're not sure of. More practice of what you're already okay at, and a chance to go back in time and have that earlier work that's really going to help your understanding. So anything here today you're not sure of. Okay, thank you, bye-bye. I hope you enjoyed it. Okay, so I'm sharing your results. Yeah, I'm sharing your results. Okay. So if you get 100%, that means you got all 5 questions correct. If you did 100% of the questions, it means you did all 5. 80%, you got 4 right. 60, you got 3. 40, you got 2. And 20%, you got 1. Okay. So if you got 100%, it's good. You're showing that you are confident in these fractions. Okay. If you got 60%, please join lesson 1 and 2 next week. Please, please, please. Because you can join them and you can really build up your confidence. Okay. You can really build up your confidence. So well done. Well done. Now, we are going to look at some adding and taking away of fractions. Okay. So now that we've got our connection back, hey, 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 happy days, and we don't seem to be lagging anymore, let's just drop down again. And first of all, let's look at some straightforward addition where you have got the same denominators. Okay, we've done some of these already where you've got the same denominators. Okay? Just dropping down where you've got the same denominators. So let's look at, first of all, oh, I haven't dropped it down, still there with me. There you go. Let's look at 8. Let me just curl this over, fold this over so that we can zoom in on the number line that we are using. So this is a fraction number line. As you can see, it goes from 0 to 1 whole 1. And I've drawn the 8s in as well so that you can see them. Okay, 1 8 is coloured in, no 8s there, 2 8s, 3 8s, 4 8s, 5 8s, 6 8s, 7 8s, 8 8s. Okay, so using what you know already or the number line, okay, using what you know already or the number line, let's do some adding and taking away. So let's do some taking away. I won't cover up there. So what is 6 8s take away 2 8s? 6 8s take away 2 8s. 6 8s take away 2 8s. There's 6 8s. And I'm going to jump back 2 steps. 1, 2. So 6 8s take away 2 8s is 4 8s. Oh, a little wobbly 8 on the side there. Okay, let's do an addition. Let's do an addition. 2 8s. Oh, no, I've changed to pink paper and my second screen still tells me we're on yellow. That tells me you are not quite with me. There we are, you've joined 2 8s plus 3 8s. So there's 2 8s. And I'm going to jump on 3 8s. 1, 2, 3. 5 8s. Okay, 5 8s. But what happens when the denominators are not the same? What happens when the denominators are not the same? And you have to do some additions when the denominators are not the same. Then you have to make them the same. And you have to make the denominators the same. So if we are going to, all my pens are over here. So if we are going to look at 3/5 and 2/15, we are looking for the lowest common multiple. Now we straight away know that that's a multiple of 5 and there's 5. So finding the lowest common multiple, it is 15. Some of you already done it. So we're going to put them both over 15. Remember, whatever you do to the bottom, you've got to do to the top. Otherwise, you change the relationship between the numerator and the denominator. So to make 5 15, I had to multiply by 3. So I've got to multiply by 3 the top. So 9. I don't have to do anything to make that 15, so I don't do anything to the top. So the answer is 11/15. We can you get this? We always look, can we simplify? No, we cannot. We cannot simplify. So the answer stays as 11/15. Okay? The answer stays at 11/15. So let's look at the next one. Let me rub this off. So the next one is 4 twelfths plus 1/3. 4 twelfths plus 1/3. Okay, if you've got some paper at home, which you should have pen and paper ready, you can work that out. Got some paper. Okay, some paper. Then you can work that out at home. So we are looking the lowest common multiple. Now we know our 3 times table, so we know that 12 is in the 3 times table. So we don't have to go above 12. We can put the lowest common denominator as 12. Really need to know our tables. If you've got any sluggy lagging in your tables, you've got to work at it. So let's put them both over 12. Nothing. To make that 12, we just leave it the same. So we have to do the same with the numerator. To make that 12, we have to multiply by 4. 4 3s are 12. So we have to do the same to the numerator. So we end up with 8 twelfths. Is that the simplest? No, it's not, because some of you have already done it. Now we're looking at the highest common factor. 8 won't go into them both. Next down is 4. 4 will. Divide that by 4. Gives us 2. Divide that by 4. Gives us 3. So the answer is 2/3. The answer is 2/3. Yeah, 8 twelfths, but we can simplify that. Simplified to 1/3. Yeah. Simplified to 1/3. 2/3, sorry, somebody's put 1/3. Very complicated way of doing that. Okay, let's have a look at another one. Let's have a look at another one. We'll do a takeaway this time. 4 ninths take away 1/3. 4 ninths take away 1/3. 4 ninths take away 1/3. Okay, put them over the same denominator. Don't make life hard for yourself. That's in the 3 times table. So the lowest common multiple is 9. So we're going to put them both over 9. What did I have to do to 9 to put it over 9? Nothing. So I do nothing to the numerator. What did I have to do to 3 to make it 9? I had to multiply by 3. So I have to multiply by 3. So 4 ninths take away 3 ninths equals 1/9. Can we simplify it any more? No, sirree, we cannot. So the answer is 1/9. Brilliant. Okay, let's do another one. Whoa, ho, ho. Okay, let's see who's awake. Who is awake? Who is awake? I need a drink of water for this one. Who is awake? Is 3 a multiple of 8? No, it is not. 3 is not a multiple of 8. So let's look at the multiples of 3. 3, 6, 9, 12, 15, 18, 21. Just hit it. One that I know is in the 8 times table. Would have been easier if I started with the 8, really. So the first multiple of 3 I came to, that 8 could go into, was 24. So I know I'm going to put them over 24. Okay. What do I need to do to 3 to make it 24? Well, 1, 2, 3, 4, 5, 6, 7, 8. I need to multiply by 8. So I'm going to do the top by 8. 8 times 1 is 8. What do I need to 8 to make it 24? 8, 16, 24. 3 8s are 24. So multiply the top by 3. Okay, 3 6s are 18. Oh. Does that mean I can't do it? What about this? What have I got over here? Got loads of thirds over there. Loads and loads. So I can take a whole one away. Take away a whole one. And when I bring that over there and I make it into 24, How many 24ths make a whole one? How many 24ths make a whole one? Well, it's the same as 24 24ths. So I can say, okay, don't worry, I'll take one away from there and I will give you 24 24ths. So now I've got 24 24ths plus 8. Well, let's do that first. That's 32 24ths I've got altogether then. Now I can say 32 take away 18. I will take away 10 is 22, take away 8. You got it? 14. We just double check. 18 and 4 is 22, 32. So I've got 14 24ths left over there, but I've still got one whole one. So the answer is one whole one and 14 24ths. You can simplify that. Highest common factor. Not the simplest answer. Highest common factor. Well, it's not 12. It's not 6. It's not 3, but it is 2. So divide by 2, 7. Divide by 2, 12. So the simplest answer is 1 and 7 twelfths. 1 and 7 twelfths. Oh, and I can see quite a few of you have already got that 1 and 7 twelfths. Now we are going to do, because time has run away from us again, next week we'll be doing some problem solving with this. So it will assume that you can add and subtract fractions with mixed denominators. If you think, I don't think I can do that, okay, I want you to join the 10 and 11 o'clock lessons. And then you can join the 12 o'clock one as well, okay? But we're going to be looking at problems involving these, so solving problems. I'm going to finish off with an assessment. Again, if you do not get at least 80%, please, please, please join the earlier lesson next week. Okay, it's a great opportunity for you to really, really get more confident. It's a great opportunity for you to have the chance to look at some of the things that in school you might not have the chance to go over again, taking your time, being on your own, getting a chance. So let's have a look. Alrighty, okie dokie, okay. Let's have a look at this last assessment of today. Okay, so question 1, you've got 3/7 and 4/11. Okay, so I'm not going to go through these because these are an assessment. You will know whether you got the score right. Okay, we'll have a look when you get the score. If you're not confident with your answers, there are 3 questions here. So 100% will be all 3, 66 will be 2 right, 33 will be 1 right. So if you do not get them all, if you don't get 100% on this one, I want you to join me on the earlier lessons, okay? Because we'll build up to these things and we'll do some of the steps in thinking that come before, and that will give you more confidence, and then you can come back to this lesson as well then. Okay, well done. Let's just end voting. A few more moments. Okay, let's end the voting. Share results with you. Okay, so if you got them all right, it means you're like really confident. If you didn't, it means we need to do a little bit more work on the earlier stages. Okay, this common denominator and highest common factor can be a little bit confusing. But once you do more of the work that comes before it, it just becomes really obvious. But I will say, if you are not really sharp on your tables, you really help yourself by brushing up on those tables, because you have to be able to look at the multiples and think, yeah, I can just see that's in that timetable. If you've got to think, oh, I'm not sure, then it's another stage to think about. You really have to work on your tables. So well done for those who got 100%. If you didn't, please join the earlier lesson next week. Okay, we're here at 10, 11 and 12, lesson 1, lesson 2, lesson 3. Next week, lesson 3 will be all problem solving. So if you're not confident and you haven't had a chance to look at the other lessons, it might wobble you a little bit. Okay, so well done everybody. Let me know what you enjoyed about the lesson today. Give me some feedback, please. No reason to feel. Why would you feel embarrassed? Absolutely no reason to feel embarrassed. Nobody knows who you are. This is the brilliant thing about the internet. I know we have to be careful, but on the internet, nobody knows who you are. You don't even have to use your real name. Nobody knows how old you are. So if you join those earlier lessons, there's nothing to feel embarrassed about, because nobody knows how old you are anyway. And I even know that I have an adult who is struggling with maths who joins those lessons. Okay. Somebody who struggles with maths, who comes in those lessons and joins in and has told me that they're really helping. Okay, so please, you do not need to use your real name. You use a username. Do not give any information about yourself. I'm not acknowledging your names at all. I'll never ask you where you live or where you are from, other than like London, South London, where nobody would be able to pick you out, Manchester. Okay, you do not need to feel embarrassed at all. Yeah, good. You did good work, because the questions were really interesting. Oh, nice. A bit of a challenge. Good. Yeah, so great. Some great feedback. Okay, this is the challenge lesson. So we do a little bit of explaining, but this is the challenge lesson. Lesson 2 is a little bit more explaining and some pictures. Lesson 1 is very pictorial, very showing you objects. So it's great. Nobody knows how old you are. Do not worry. Please jump on those lessons, because, at school, you wouldn't have a chance to go back into year 3 or year 4 and say, can I just come and join these lessons and miss my own lesson? That would be really hard to do. But you can do that here, and nobody knows, just you. Okay, so please. Oh, thank you. The teacher, well, I always try to be, I should be a teacher. I am a teacher. Oh, lovely. I should be a teacher. I am a teacher. I think you mean I should be back in school. I do miss being in school in the classroom. I loved being in the classroom with my children. I absolutely love it. And I am in contact with some of the children that I taught when I was first teaching. And some of them are quite old now. And they all talk really fondly about being back in class. Okay. So really lovely to be with you. Love you to spend the time. Please come back next week. Remember what I said. Any wobbles? Join us earlier. Take care, and I'll see you next week. Bye-bye, everybody.